One of our subscribers asked us to create a lesson on operations on integers. So let's begin by defining what integers are. Integers are positive whole numbers, these are the set of counting numbers, negative whole numbers, and zero. If we put these numbers on the number line, it would look like this. Any number to the right of 0 are positive, any numbers to the left of 0 are negative, and 0 is neither positive nor negative. Any number to the right is greater than the number to the left. For example, 5 is obviously greater than 2, and 1 is greater than 0. And 0 is greater than negative 2, because you can think of 0 as you have nothing, but negative 2 you can associate with a debt of $2, for example. So it's better to have nothing than to owe something. Negative 2, for example, is greater than negative 5, because in the case of negative 2, you are only short by, let's say, $2, but for negative 5, you owe somebody $5. It's better to owe 2 than to owe 5. But we need to emphasize that integers are whole numbers. This does not include 1.5, 1.1, 1/2. This does not include fractions. This only include positive whole numbers, negative whole numbers, and 0. With that as our definition, let's orient ourselves with the tool that we are going to use to understand this lesson. And I think the best way to understand this lesson is to use the same method used by the Chinese when they first used the systems of rod to represent positive and negative. So these are our algebra tiles. We are going to use red tiles to represent negative, and we are going to use yellow tiles to represent positive. There is a very important concept before we proceed with our operations. We call this as the zero pair. For the zero pair, we say that if you have a positive 1, and a negative, if you combine these two, they will form a zero pair, because negative 1 plus positive 1, negative is the red, positive is the yellow, the result is 0. And since the value is 0, you can just remove this pair without changing the value of the equation or the value of the expression. And in solving addition and subtraction of integers, removing all this 0 pair is the key. Let me show you. Let's have these examples. How do we represent the addition of 4 plus 5? So using our algebra tiles, you just get positive 4. So we need 4 yellow and 5 yellow. So this is how we represent 4 plus 5. And the plus sign means we are going to combine. So we combine 4 and 5, the answer is 9. If we have negative 3 plus negative 2, we need 3 red, that's negative 3, and you add negative 2. So this is negative 3 plus negative 2. Plus means we combine, so combining these two results to negative 5. So negative 3 plus negative 2 equals negative. I want you to observe the sign, because later on in your journal I will ask you to write the rules for addition of integers. So negative 8 plus positive 3. So negative 8 plus positive 3. The plus sign says we are going to combine these two together. When you have red and yellow, we have 0 pair. So we need to remove all those 0 pairs. So this is one pair. This is another pair. And this is another pair. So by removing all these 0 pairs, we are left with 5 red. So we now therefore say that negative 8 plus 3 equals negative 5. That's now what I mean by using the 0 pair most of the time when you are dealing with addition and subtraction of integers, which we are going to show later. If you have 7 plus negative 2, we represent it this way. So you have 7 yellow and negative 2. So you have 2 red. And then we remove the 0 pairs. This one and this one pair. These two, another pair. So what's left is 5 yellow, and yellow is positive. So this is equal to positive 5. Next. If you have negative 4 plus 4, so you have negative 4 plus 4. So remove all the 0 pairs, combine them, and remove all the 0 pairs. Remove this, remove this, remove this, and remove this. So what's left is nothing, 0. If you have this problem, negative 5 plus 7, that's negative 5. 7 is positive, so we need yellow. So negative 5 plus 7 plus negative 3 plus 2. Negative 5 plus 7 plus negative 3 plus 2. So let's combine them all together. And then remove all the zero pairs. Remove this, remove this, remove this, remove all the zero pairs. Whatever's left is the answer. So our answer is positive 1. Now, I want you to observe all of this. I want you to observe all of this and try to create a rule for addition of integers. So let's pause for a moment. Okay, assuming that we already have finished writing your journal entry, these are now some of the observations that you can have. The sum of two positive integers is positive. So positive 4 plus positive 5, the sum 9 is also positive. The sum of two negative integers is negative. Look at this. Negative 3 plus negative 2 equals negative 5. So negative and negative, the sum is negative, but you add 3 and 2 to get 5. 4 and 5, both are positive. The sum is positive 9. You add 4 and 5. Next, to add one positive and one negative integer, let's say one positive and one negative. So 7 is positive, negative 2 is obviously negative. So what did we do? We subtract 7 and 2 to get the 5. And look for the sign of 7 and the sign of negative 2. The absolute value means just get the positive. The absolute value of 7 is 7. The absolute value of negative 2 is positive 2. Which one is greater, 7 or 2? Obviously 7 is greater. So the sign of this 7, which is positive, becomes the sign of 5. On the other hand, if you have negative 8 and positive 3, the signs are different. You subtract 8 and 3 to get the 5. And then you look at the absolute value of 8. Just ignore the sign. And the absolute value of 3, which is also positive. Which one has greater value, 8 or 3? 8 has greater value than 3. Then, whatever the sign of this number, it's negative, that becomes the sign of your answer. Let's look at some of the examples here. When you have one negative and one positive, but they are the same numerical value, the same absolute values, the sum of negative 4 plus positive 4 equals 0. And we call them as additive inverse, which we are going to use in our discussion of subtraction of integers later on. So to summarize the rules, when you read the rules in the math textbook, you will find this very, very abstract, especially number 3. To add one positive and one negative integer, find the absolute value of each integer, subtract the smaller from the larger in step 3a, take the sign of the numbers with the higher absolute value as the sign of the sum. That sounds very, very abstract for elementary students, but if we go back to how the Chinese first conceptualized the system of rods for positive and negative integers, these rules make a lot of sense. So the goal now is we progress from something that you can see, that you can visualize, that you can understand, but we do not stop there. You must be able to perform addition of integers without the use of these crutches, without the use of the manipulatives. And the best way to do that is using mental computation. In your mind, you can imagine these rods, these colors, these red squares, yellow squares, and you'll be able to recall the rules when you are confused. Let's move to subtraction of integers. Let's define first what is subtraction. Subtraction is the addition of the additive inverse. What does it mean? If I have 3 minus 5, the operation is minus. I can rewrite this as addition this way. This is just the same as writing it as 3. Instead of minus, we add, because subtraction is adding the additive inverse. Instead of this minus sign, we perform addition. But we are going to add the additive inverse of the next number of the subtrahend, which is 5. So What is the additive inverse of 5? Its additive inverse is the opposite sign, negative, and then 5. These two are equivalent. One is written in terms of subtraction operation, the other is written in terms of addition. Because by definition, subtraction is addition of the additive inverse. This is very important because if you know how to convert subtraction to addition, you don't have to memorize two rules for addition of integers, one for subtraction and one for addition. You only need one rule, and that rule is for the addition of integers, because the moment that you are able to convert from subtraction to addition, then you can apply the rule for addition of integers. So when you have 3 plus negative 5, using our manipulative again, we have positive 3, and you have negative 5, and then we combine, because we already converted from subtraction to addition, so we have to combine these two now, and then remove the 0 pairs. So the answer is negative 2. Next, if you have negative 2 minus negative 7, again, the process is to convert them to addition. So copy the first number, negative 2. Change the subtraction operation to addition, and get the additive inverse of the subtrahend from negative 7 to positive 7. And you get here, negative 2 plus 7. Now that you are familiar already with these manipulatives, you can now think of removing two 0 pairs. Because of this negative 2, you need to remove positive 2 out from the 7 to remove all those 0 pairs. And what would be left would be positive 5. Concretely, it looks like this. You have negative 2, and we have positive 7 at the right. And then when we combine and remove the 0 pairs, what is left is positive 5. Okay? What if you have this one? Negative 6 minus 2. Still the same procedures. Copy the first number, change subtraction to addition, get the additive inverse of the second number. From positive 2, that becomes negative 2. And then you have negative 6. Imagine 6 red squares. You have 2 red squares, negative 2. Together you have 8 red squares. So this is equal to negative 8. If you have negative 5 minus negative 5, so that is equal to, copy the first number, 5. Change the minus sign to addition. Get the additive inverse of negative 5, which is 5. And 5 plus 5 equals 10. We don't need any manipulatives for that. Okay, negative 4 minus negative 4. So we do it this way. Convert to addition. Copy the first number. Change the minus sign to plus sign. Change the second number to its additive inverse from negative 4 to positive 4. So imagine now you have 4 red squares and 4 yellow squares. You will form 4 0 pairs, so the result is 0. Now when you have several items like this, don't be confused. Just do it step by step. So copy the first number, negative 7. Change this minus sign to plus sign. Get the additive inverse of 2, which is negative 2. Change this minus sign to plus sign. And then get the additive inverse of negative 3, that is positive 3. Change the minus sign to plus sign again. And get the additive inverse of 1, which is negative 1. So you now have negative 7, negative 2, positive 3, and negative 1. If you are using manipulatives, it will look like this. And you have 2 red, and you have 3 yellow, and you have 1 red. Then remove all the 0 pairs. Remove this. remove this 2, remove this pair. What's left is our answer. You have 2, 4, 6, 7. So this is equal to negative 7. Without the use of algebra tiles, you gather all the negatives. You have negative 7 and negative 2 gives you negative 9. And you have negative 1 here gives you negative 10. Plus, you have positive 3. So, negative and positive, you remove all the 0 pairs. So this is positive 3. You need to remove 3 negatives there. So what would be left is 7 red, or negative 7. Okay, let's pause for a moment, and I want you to observe what happens here and come up with a rule for the subtraction of integers. Okay, assuming that you have already written your reflection in your journal, this is one suggested answer. We convert first from subtraction to addition by using the definition of subtraction as adding the additive inverse. Once done, you just apply the rule for the addition of integers that we already studied. So there are no two rules. There is just one rule, which is for the addition of integers. What we have here is just an extra step to convert from subtraction to addition, and once converted, we can apply the rule for addition of integers. Let's move to multiplication. It says 3 groups of 2. So you have 2, and you have 3 groups of that. One group, the second group, and the third group. So 3 groups of 2. And obviously the answer is 6. When you have 2 times negative 3, you can think of that as 2 groups of negative 3's. So that's the first group. This is the second group. And there are 2 groups of them. Together, that gives us negative 6. Negative 6 because red is negative. When you have negative 3 times 4, it's hard to imagine negative 3 groups. What you're going to do is cover this sign first, and then flip the answer later on. So 3 groups of 4. First group, second group, and the third group of 4. Together, it's 12. But since there's a negative sign here, we are going to flip everything over to indicate the opposite sign. And so, we have negative 12. And then, when you have negative 2 times negative 4, again, cover the sign. Think of this as 2 groups of negative 4. So you have 2 groups of negative 4. And then, the result, flip the sign. Because of this negative sign, we're going to flip all these squares over. And our answer is positive 8. What if we have 3 times 0? 3 times 0. So if we have 3 times 0, 3 groups of nothing. So no matter what you do, there's nothing. So this is also 0. So multiplication by 0 always result to 0. What if you have several like this? You have negative 2 times negative 3 times negative 4. What you can do is cover this first. Think of this as 3 groups of negative 4. 1, and this is the third group. 3 groups of negative 4. And since there's a negative sign here, we're going to flip everything over. So we now have positive 12. And then this one says 2 groups of this, so we need another positive 12. So we need 2 groups of positive 12. But these negative signs, we're going to flip the sign over again. And so our final answer is negative 24. Okay? Now at this point, I want you to observe the signs and the operation and come up with your own rule for multiplication of integers. And I want you to write your answer in your journal notebook. Okay, assuming that you have done that already, let's look at the rules. When you multiply integers with the same sign, both positive, 3 times 2, the answer is positive. Both negative, negative 2 times negative 4, the answer is also positive. So, the same sign, positive and positive, the product is positive. Negative times negative, the product is also. And that can be verified by our observations here. And then, different signs, meaning one positive and one negative and one positive, the product is negative. Let's look at this. One positive and one negative, our product is negative 6. One negative and one positive, our product is negative. And when you have odd number of negatives, like you have one negative, another negative, another negative, when you have odd number of negatives, the product is also negative. If you have even number of negatives, if you have 4 negatives, 6 negatives, and so on, if you have even number of negatives, the product would be positive. Now, let's visualize division of integers. When we have 6 divided by 3, you interpret it this way. You have 6 items, and you are going to group them or divide them into 3 equal parts. 1 part, 2 parts, 3 parts. And then the answer is how many items are in each group. There are 2 items in each group. So 6 divided by negative 3 equals 2. When you have negative 6 divided by 2, negative 6. And we are going to group negative 6 into 2 groups. So first group, another group. So 2 groups. How many items are in each group? There are 3, but red. So that means negative 6 divided by positive 2 is negative 3. And you can go back, negative 3 times positive 2 equals negative 6. That is always true. Okay, let's move to the next one. Negative 6 divided by negative 2. Again, like in multiplication, it's hard to divide this into 2 negative groups. What you're going to do is cover the sign first. Just think of negative 6 group into 2 groups and count how many items are in each group. But because of this negative, we are going to flip this over again. So our answer is positive 3. And then 4 divided by negative 2. So you need 4 items. And you have to divide it first into 2 groups. One group, first group, second group. And then because of this negative sign, we have to flip over the quotient. So we get negative 2 as our answer. Again, I want you to observe and come up with your rule for division of integers. Okay, assuming that you have done that already, so it's the same rule for multiplication. The quotient of 2 positive is positive. The quotient of 2 negative integers is also positive. And for different signs, the quotient is negative. You can verify it here. Positive divided by positive is positive. Negative divided by negative is positive. But when the signs are different, the quotient is negative. Okay?